Hi everyone, myself Sibina, faculty at Silver Hills Public School, Chemistry Department. In this session, we are discussing about nomenclature of aldehydes and methods of preparation of aldehydes. So, let us consider nomenclature of aldehydes. The first member in aldehyde family is methanol, HCHO. It contains only one carbon, so the corresponding alkane, methane, so it is methane, and the common name is formaldehyde. Okay. The next member in aldehyde family is ethanol, CH3CHO. There are two carbon in ethane. E is replaced by the suffix al, so it becomes ethanol, and the common name of ethanol is acetaldehyde. Let us consider another example for aldehyde, CH3, CH2, 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 CHO. That means it contains 5 carbon including aldehyde family, aldehyde group. So, it is called pentanol, and the common name of pentanol is valeraldehyde. Let us consider another example, but here there is a difference is there. Other than aldehyde, there is a chlorine group is there, right, and the chlorine group is present on the second carbon. When we consider the priority order, aldehyde has more priority compared to chlorine. So, the CHO carbon should be the first carbon. So, when we number this group or when we number this compound, CHO carbon should be the first carbon and chlorine carbon or the carbon bearing chlorine will get second position. So, the name of this compound it is 2-chloropentanol, and pentanol is valeraldehyde. So, if there is a chlorine on the second carbon, the common name of this compound is 2-chlorovaleraldehyde. Let us consider another example for aldehyde. It is CH3, CH2, CH2, CHO. Including CHO carbon, there are total 4 carbons are there. So, the alkane is, if an alkane contains 4 carbon, it is butane. So, E is replaced by butane, E is replaced by the suffix Al. So, it becomes butanol. Common name of butanol is butyraldehyde. So, butanol 3-methyl butanol, and the common name of 3-methyl butanol is isovaleraldehyde. Now, let us consider aromatic aldehyde, benzene ring with the CHO group. It is called benzaldehyde. Benzaldehyde is a common name. Even though it is a common name, it is recommended by IUPAC, and it is also called benzene carbaldehyde. And this is a 5-membered ring with a CHO group, and the name of this compound is cyclopentane carbaldehyde. Okay. Now, we are moving to the main topic, it is methods of preparation of aldehydes. And the first method to prepare aldehyde, it is Rosenman reduction reaction. It is from acyl halide. A Rosenman reduction reaction is a conversion of an acyl halide into aldehydes. Let us we can check how can we convert an acyl halide into aldehydes. Acid chloride gets converted to aldehyde. It is the addition of hydrogen in presence of a catalyst is called catalytic hydrogenation process. So, in the case of Rosenman reduction reaction, acid chlorides are treating with hydrogen in the presence of a catalyst called palladium supported over barium sulfate. That is called Rosenman reduction reaction. Addition of hydrogen in the presence of palladium supported over barium sulfate, and it is poisoned by trace amount of sulfur or quinoline is called Rosenman reduction reaction. So, it is a conversion of an acyl halide by treating with H2 in the presence of palladium catalyst supported over barium sulfate, and the reaction is poisoned by trace amount of sulfur or quinoline is called Rosenman reduction reaction. This is a general reaction for Rosenman reduction reaction. Acyl halide, general formula RCOCl. It's treating with H2, presence of palladium, supported over barium sulfate, gives RCHO plus byproduct hydrochloric acid. So, this Rosenman reduction reaction is used only to prepare aldehydes. Ketones we can't prepare by using Rosenman reduction reaction. So, let us consider the examples for the Rosenman reduction reaction. So, CH3COCl. There are 2 carbon in CH3COCl. So, the name of this compound ethanoyl chloride. So, ethanoyl chloride on treating with H2, presence of palladium, supported over barium sulfate and trace amount of sulfur or quinoline, it gets converted to ethanol. So, when we consider this reaction, we can see that the number of carbon atom remains the same. There is no change in the number of carbon atoms. Ethanoyl chloride contains 2 carbons and ethanol also contains 2 carbons. So, during Rosenman reduction reaction, there is no change in the number of carbon atoms. If it is an ethanoyl chloride, the product it is ethanol. If it is a propanoyl chloride, the product it is propanol. If it is butanoyl chloride, the product it will be butanol. So, there is no change during the reaction of Rosenman reduction reaction. So, if it is ethanoyl chloride gives ethanol, propanoyl chloride gives propanol, butanoyl chloride gives butanol. Aromatic aldehydes can also be prepared by using Rosenman reduction reaction. For example, benzoyl chloride. In order to prepare benzaldehyde, we have to use benzoyl chloride. What is the formula of benzoyl chloride? C6H5COCl. So, this benzoyl chloride on treating with H2 in the presence of palladium, supported over barium sulfate and trace amount of sulfur or quinoline gives benzaldehyde. Number of carbon atom, there is no change. Benzoyl chloride gives benzaldehyde. Okay. So, there is a limitation for this Rosenman reduction reaction. Formaldehyde cannot be prepared by using Rosenman reduction reaction. What will be the reason for it? Because in order to prepare formaldehyde, formal chloride should be used. The acid halide that we have to use, it should be formal chloride. And this formal chloride is not stable at room temperature. So, we can't prepare formaldehyde by using Rosenman reduction reaction. And the reason is that in order to prepare formaldehyde, we have to use formal chloride, and formal chloride is not stable at room temperature. And when we discussed this Rosenman reduction reaction, we specified that the reaction should be in presence of trace amount of sulfur or quinoline. Palladium, it is a catalyst, right. So, what is the function of sulfur or quinoline during this Rosenman reduction reaction? So, it is poisoning the reaction. What is meant by poisoning a reaction? Poisoning means during Rosenman reduction reaction, it converting an acyl halide into aldehydes. This is a reduction process. So, aldehydes, we know that it is more reactive than ketones. So, it has a tendency to again reduction. So, in order to prevent the reduction process of aldehydes, we have to use the sulfur or quinoline, and that reaction is called poisoning of a reaction. So, further reduction of aldehydes, it gets prevented in the presence of sulfur or quinoline. So, Rosenman reduction reaction, it is a conversion of an acyl halide into aldehyde by treating with H2, palladium catalyst, supported over barium sulfate and trace amount of sulfur or quinoline. So, RCOCl gives RCHO, ARCOCl gives ARCHO. Okay. Now, we are moving to the second methods of preparation of aldehydes, and it is reduction of nitriles. There is a name for this reaction. Reduction of nitriles into aldehydes is called Shithin reaction. How can we convert an alkyl cyanides into aldehydes? It is by treating with stannous chloride SnCl2 and hydrochloric acid in presence of dry ether media followed by hydrolysis gives aldehydes. So, the reaction should be in presence of stannous chloride and hydrochloric acid. First we will get an intermediate called imine, and this imine on hydrolysis gives aldehyde. This is the general reaction for Shithin reaction. RCN alkyl cyanide, RC triple bond NS alkyl cyanide, and that is on treating with SnCl2 and hydrochloric acid. First it gives an intermediate called RCH double bond NH. It is called imine. A compound containing a C double bond N is called imine, and this imine on hydrolysis, further hydrolysis gives RCHO. And this reaction also, when we consider this reaction also, RC triple bond N gives RCHO. That means there is no change in the number of carbon atom. Number of carbon atom remains the same. RC triple bond N gives RCHO. What are the conditions for a Shithin reaction? SnCl2 plus HCl. First it gives imine, and this imine followed by hydrolysis gives aldehyde. This is an example for Shithin reaction. CH3 C triple bond N on treating with SnCl2 and hydrochloric acid. First it gives an imine, and this imine on further hydrolysis gives CH3 CHO. So, here also we can see that CH3 C triple bond N gives CH3 CHO. That is, cyanomethane gets converted to ethanol. So, cyanide also contains 2 carbon and this aldehyde also contains 2 carbon. And aromatic aldehydes can also prepared by using Shithin reaction. And let us consider the methods of preparation of benzaldehyde by using Shithin reaction. And here the cyanide is benzonitrile, and this benzonitrile first treating with SnCl2 and HCl, first gets converted to imine, and this imine further hydrolysis gives corresponding aldehyde. So, both aliphatic compounds, aliphatic aldehydes and aromatic aldehydes can be prepared by using Shithin reaction. Condition for Shithin reaction: cyanides treating with SnCl2 and hydrochloric acid. First it gives an imine, and this imine further hydrolysis gives an aldehyde. And the third method of preparation of aldehyde, it is from alcohols. How can we convert an alcohol into aldehyde? It is by a process called oxidation. But when we consider an oxidation reaction, it should be by using an oxidizing agent. There are 2 types of oxidizing agents are there: strong oxidizing agents and mild oxidizing agents. Strong oxidizing agents means first we will get a compound, and again further oxidation is possible if we are using a strong oxidizing agent. Example for strong oxidizing agents are acidified potassium dichromate K2Cr2O7 or acidified or alkaline KMNO4 potassium permanganate, or we can use CrO3 chromium oxide and sulfuric acid. So, these are the examples for strong oxidizing agent: acidified K2Cr2O7 for alkaline KMNO4 or chromic oxide and sulfuric acid, acidified chromic oxide. But second type of oxidizing agent is PCC, pyridinium chlorochromate, PCC. Or another example for mild oxidizing agent is PDC. PCC is also called Corey's reagent. While we are using PCC or PDC, the main advantage of PCC and PDC is that it does not affect the double bond. It does not attack the double bond. Double bond will not be get oxidized, or during the reaction it only oxidizes an alcohol or aldehyde group only. If we are using a mild oxidizing agent like PCC or PDC. And one more thing, the reaction will be stopped in one step process. Further oxidation will not occur if we are using PCC or PDC. Now let us consider an example. RCH2OH. RCH2OH is the representation of a primary alcohol, that we know it. So this primary alcohol on oxidation, we can use either strong oxidizing agent or mild oxidizing agent. If we are using a mild oxidizing agent like PCC or PDC, the product it will be an aldehyde. Okay. But if we are using a strong oxidizing agent like acidified K2Cr2O7 or alkaline KMnO4 or CrO3 in H2SO4 sulfuric acid medium, that time first aldehyde is forming and this aldehyde again oxidized and gets converted to carboxylic acid RCOOH. So we can't stop the reaction up to aldehydes if we are using a strong oxidizing agent. So primary alcohols on oxidation, first it gives aldehyde, further oxidation gives carboxylic acid. If we are using a mild oxidizing agent in this condition, the reaction will stop up to aldehydes only. But for example, ethanol CH3CH2OH on oxidation gives ethanol CH3CHO. So there is no change in the number of carbon atom. Number of carbon atom remains the same. Alcohol contains 2 carbon and the aldehyde also contains 2 carbon. So during the oxidation of a primary alcohol into aldehyde, there is no change in the number of carbon atom. Number of carbon atom remains the same. If we are using a 2-membered alcohol, aldehyde also contains a 2-membered carbon. But let us consider a secondary alcohol. Secondary alcohol means R-CHOH on oxidation, and it will be gets converted to a ketone. So secondary alcohol on oxidation, either we are using a strong oxidizing agent or a mild oxidizing agent, the product it is ketone. Okay. So secondary alcohol cannot be used for the method of preparation of aldehydes. It is secondary alcohol always gives ketone during oxidation. Let us consider a primary alcohol. Name of this compound. First carbon, there is an OH. Second carbon, there is a methyl group. So name of this compound 2-methyl propan 1-ol. And this is on oxidation gives 2-methyl propanol. So only this CH2OH part get oxidized into CHO. So in this condition we can use PCC or PDC, but if we are using alkaline KMnO4 or acidified K2Cr2O7, what we have to do? The product which are forming, that should be continuously removed. Otherwise it will be gets converted to the corresponding carboxylic acid. Next method, it is by catalytic dehydrogenation of alcohols, either by oxidation or by catalytic dehydrogenation of alcohols. It is by using a copper catalyst at 573 Kelvin. So let us consider primary alcohol RCH2OH. RCH2OH is a representation of a primary alcohol. So primary alcohol on treating with copper at 573 Kelvin gives RCHO. So RCH2OH gives RCHO. Example, CH3CH2OH plus copper at a temperature of 573 Kelvin gives CH3CHO. So, ethanol gives ethanol, propanol gives propanol, butanol gives butanol, like that. Okay. So, there is no change in the number of carbon atom. If it is an ethyl alcohol, it will be gets converted to ethanol. If it is a propyl alcohol, it will give propanol during the dehydrogenation process with copper at 573 Kelvin. The temperature is very important. Only this temperature, that is 573, only the dehydrogenation of alcohol will occur. So, by treating with copper at 573 Kelvin, primary alcohol gives aldehydes. If we are using a secondary alcohol, the product, it will be a ketone. So, secondary alcohol on treating with copper at 573 Kelvin gives a ketone. For example, R, CHOH, R dash. On treating with copper at 573 Kelvin gives a ketone. But if you are using a tertiary alcohol, it not be gets converted to a carbonyl compound. Okay. It will be gets converted to alkene. And the reason is that instead of dehydrogenation reaction, a tertiary alcohol on treating with copper at 573 Kelvin gives an alkene, because instead of dehydrogenation process, dehydration occur. What is meant by dehydration reaction? Dehydration means it is the removal of water molecules. So, a molecule of water gets removed from OH and H from an alkyl group gives corresponding alkene. For example, let us consider this tertiary butyl alcohol. So, when it is treating with copper at 573 Kelvin, a molecule of water gets eliminated, means OH from here and H from one CH3 group. Water molecule gets eliminated and gets converted to isobutene. What is the IUPAC name of isobutene? It is 2-methyl propene. So, primary alcohol on treating with copper gives aldehyde, secondary alcohol on treating with copper gives ketone, and tertiary alcohol treating with copper gives an alkene, because instead of dehydrogenation reaction, dehydration occurs. Now, we are moving to the methods of preparation of aromatic aldehydes. How can we prepare aromatic aldehydes? By different methods, and the first one is called ITAD reaction. So, what is ITAD reaction? ITAD reaction is alkyl substituted benzene on treating with CrO2Cl2, that is chromyl chloride, in CS2 medium. First it gives a chromium complex, and that chromium complex on hydrolysis it gives the aldehyde, and that is aromatic aldehyde. So, ITAD reaction is a conversion of an alkyl substituted benzene into an aromatic aldehyde. If you are using toluene on treating with CrO2Cl2, presence of CS2 medium, first it gives a chromium complex, then followed by hydrolysis gives benzaldehyde. And the next method, second method of preparation of aromatic aldehyde is by using chromic oxide. So, here also any alkyl substituted benzene on treating with CrO3 and in the presence of acetic anhydride CH3CO twice O2 at a temperature of 273 to 283 Kelvin. First it gives an intermediate, and that intermediate followed by hydrolysis gives aromatic aldehyde. If it is toluene, this will be gets converted to benzaldehyde by using the reagent CrO3 in the presence of acetic anhydride followed by hydrolysis. And the third method of preparation of aromatic aldehyde is Gattermann-Koch reaction. And this Gattermann-Koch reaction is used only for the conversion of benzene into benzaldehyde. We can convert a benzene into benzaldehyde by using Gattermann-Koch reaction. So, Gattermann-Koch reaction is benzene on treating with carbon monoxide and HCl in presence of anhydrous AlCl3 and CuCl, it gives benzaldehyde. Benzene on treating with carbon monoxide, HCl, anhydrous AlCl3 and CuCl gives benzaldehyde. So, we discussed 3 methods of preparation for aromatic aldehydes. First one, ITAD reaction, alkyl substituted benzene treating with CrO2Cl2 followed by hydrolysis gives aromatic aldehyde. Second one, by using CrO3 in acetic anhydride medium, first it gives a complex and complex on hydrolysis gives aromatic aldehyde. And third one is Gattermann-Koch reaction. It is used only for the conversion of benzene into benzaldehyde. Benzene on treating with carbon monoxide and HCl in the presence of anhydrous AlCl3 and CuCl gives benzaldehyde. So, hope the session is clear for you. Thank you.